Welcome back. Let's continue with our textbook, which is the Drafting and Design for Architecture and Construction. This video starts our part 2, and that is Architectural Drafting Fundamentals. So chapter 3 begins part 2, and that is the scales and measurements. So here in this chapter, you will learn how to use an open divided scale, then how and where to use different architect scales, how to read scales from opposite sides, how to use an engineer scale, how to read a metric scale, and many other things. And there are a few terms that we will learn. Those are the architect scale, engineer scale, and large scale, full scale, fully divided scale, metric scale, open divided scales, and reduced scale. So let's start with the very first one, and that's the architect scale. So the ability to use the architect scale accurately is required not only to prepare drawings, but also when checking existing architectural plans and details. So this is the architect scale that I have here, and you can see the name. It says architect or engineer, so you won't actually mix it up. So the architect scale is also needed in a variety of related architectural jobs, such as bidding, estimating, and model building. So architect scales are either open divided or fully divided. So in fully divided scales, each main unit on the scale is a fully subdivided into smaller units using the full length scale. Then on open divided scales, only the main units of the scale are graduated or marked off all along the scale. So I highly recommend to get the scale and just see how that works. So you see the difference here, how that is marked, and also you can see the fully divided scale here. Also, when you use a scale, architect scales may be either bevel or triangular style. The triangular style has 3 sides and 6 edges. It accommodates 11 different scales and the marked units of measure. The architect scale can be used to make the division of the scale equal 1 inch or 1 foot. For example, half inch can equal 1 inch or 1 foot, or any unit of measurement such as yards or miles. And please see the pictures in our textbook. I always recommend to just go back to the textbook, see all the graphics, and just understand that, because you need to own the concept. You really need to know how that works. So play with that, play with the scale, and you will definitely understand how to apply that to the drawings. So to further understand the architect's scale, you can compare one specific distance on different scales. So you can compare like 5 foot 6 inches on the 4 different scales and see how that is represented. So the architect scale is only as accurate as its user. You really need to spend time just to play with that. And I think I will actually record a specific video just how to use it, not as part of the textbook overview, because I think that is critically important to know that you will be using that throughout your whole career. So in using the scale, always lay out the overall dimensions of the drawing first. If the width and length are correct, only only minor errors in subdimensions may occur. And if overall dimensions are correct, it's easier to check subdimensions. If one is inaccurate, another will be also. So please remember that. So when you select a scale or when you select a proportion, if the structure to be drawn is extremely large, a small scale must be used. Small structures can be drawn to a larger scale because they will not take up as much space on the drawing sheet as the large ones. So most plans show major parts of residences or any other structure, such as floor plans, elevations, and all the like foundation plans and stuff. They are drawn to 1/4 inch per foot. Construction details pertaining to these drawings are often drawn to 1/2 inch, 3/4 inch, or 1 inch per foot. So that is the scale, and it's usually shown on the bottom right of the drawing. The full scale in fractional inches may be used to draw objects full size, such as 1 inch is 1 inch equals 1 inch, or 1 foot actually equals 1 foot, or to a scale of 1 inch equals 1 foot, and so on. So those are different variations that you will see in the drawings. So when we talk about the engineer scale, that is often used for plans that show the size and features of the land surrounding a building, such as plot plans, site plans, landscape plans, and so on. An engineer scale is divided into decimal parts, and these parts are 10, 20, 30, 40, 50, and 60 parts per inch. Again, please refer back to the textbook and you will see how that works. An engineer's scale of 1 inch equals 10 feet is normally used for small sites. If a land site is very large, a scale of 1 inch per 20 or 1 inch per 30 feet may be needed to allow the plan to fit the sheet size. And again, it totally depends on the scale of the project, the size of the sheets that are going to be plotted, and other different factors. Metric scales, let's talk a little bit about that. So metric scales are used in the same manner as the architect scale to prepare the reduced size drawings. Metric scales, however, use ratios in increments of 10 rather than the fractional ratios of 12 used in architect scale. So units are related by tens, and most measurements used on architectural drawings are linear distances. The basic unit of the metric system for distance is the meter, or m. That's how we depict it. Also, prefixes are used to change the base, or meter, to larger or smaller units by units of 10. So for the American students, it's really hard to convert that, but for those who were actually educated in other parts of the world, that is the metric system that students learn there. So, and for the, let's say, European students, it's hard to adjust to the imperial system, and the other way around. So that's really interesting to know. You really need to understand that and convert it back and forth, because that is something that is used everywhere. So prefixes that represent subdivisions of less than 1 meter are like decimeter, then centimeter and millimeter. So the decimeter equals to 1/10 of a meter, or 10 centimeters. A centimeter is 1/100th of a meter, and that's 1 centimeter. And then a millimeter equals to 1/1000th of a meter, or 1/10 of a centimeter. So again, please, please, please go back to the all the images and beautiful graphics here. So when we use the scale in our drafting software, such as CAD or Revit, knowledge of architects and engineers scales is necessary for both manual and CAD drafting. In CAD drafting, the scale command is used to set a drawing object to a specific architect's engineer's or metric scale size. So, and please make sure that you set up the scale before you draw, just because, there may be confusion when you when you continue with the drawings. So here that is actually it for our chapter 3. There are a few exercises in the textbook, and I really recommend doing them just because that practice will help you understand the conversion, and that will help you understand the engineer scale, architect scale, metric system, and imperial system. Thank you so much for watching. I will see you in the next video. And the next one is chapter 4, which is conventions and procedures. Thank you again so much.